what are the available solutions that you have from the Python world. I think everyone should be aware of what Excel is. And who here does use Excel for their work, let's say on a daily basis?
Doesn't.
A dozen.
Who does use Excel on a daily basis? Okay. So most likely those of you with web programming don't need Excel. But for a lot of us, particularly for me, I'm doing forecasting. So I tend to interact with a lot of the data, and sometimes they come to me not from a database, straight from a database, but through Excel. So that's the reason why I actually had been advocating the use of Python, since it makes your life easy when dealing with large data sets. So one of the challenges I had, so this is not a picture books presentation, not following the 20-second per slide rule. Like this first slide here, that's my first reaction with the format. It's like haiku. It's a bit challenging. It's actually a bit challenging to try to fit a lot of things in 6 minutes and 40 seconds, and to move on with a discussion at a rate of 20 seconds per slide. So I hope you'll understand. Now, usually when you are presented with such a blank slide or a blank thing wherein, okay, I have Excel, I have Python, where do I start? So I think you have to first go into the level of understanding the purpose of Excel. So Excel can be boiled down into 3 functions: gathering and storing data, transforming this data, and finally presenting to it. Take a note of these 3 functions, because some parts of this are actually well suited for Python, some parts are not. For example, the presentation part is usually the challenge of most solutions right now in Python, because of Excel's charts are not really easy to deal with. Most likely Python will come into the picture on the first 2 functions, gathering the data for you or storing it in Excel and transforming it, okay? Now, of course, you also have to try to understand the internals of your Excel. Sorry for the morbid picture here. Anybody had played this game? Silly game. It's called Surgery Simulator 2013. Quite ridiculous game. Do look it up in Google, okay? Quite fun.
It was made in 24 hours and 48. It was made in 48 hours.
It was made in 48 hours. Okay, so that's an additional reason for you to listen to what Sonny was telling you earlier. A good way of actually learning programming would be through games. And if you have 48 hours, you can probably produce something like this. But anyway, going back to Excel. So remember that the basic unit of Excel are cells, and they contain values. That's the primary data in cells, and these are usually easily accessible through Python. Your problem usually falls into the metadata part, or the data about your data, usually in the form of formulas and the formatting of cells. Some of the solutions that we're going to discuss later really doesn't deal much into like extracting the formula for you or interactively dealing with that formula of the cell. Okay, so but for the data values that you have there on the Excel file, it's easy, either writing or reading into it. General guidelines, since we're talking about solutions or the approaches to have, first consider your platform. Both for where you're going to run Python and where you're going to access Excel. If you're really going to access Excel program itself, obviously you're limited to running it in a Windows platform. But if you're just dealing with the file, the Excel file format, it can be anywhere. It can be in Linux, it can be in Windows. So take note of your platform, because the available solutions will be dependent on those. Second, consider also if the libraries or the solutions are already stable or production grade. there's actually plenty of things around in Python, and I think I should introduce, especially the beginners, we call it the Python cheese shop, or PyP, so pypi.python.org. This is actually the equivalent of for Ruby, what's for Ruby? Gems. For Perl, it's called CPAN. So these are the repositories of all the available libraries that you have, which is at least officially registered to Python. The advantage of which is that we actually have package installers in Python. So some of these third-party libraries can be installed using these installers, and anything that's usually on the G shop can be easily installed. Everyone familiar, like apt in Ubuntu? Aptitude. So it works like that. It's a command line installation. Just name the library, which I will provide you later. Just name the library, it gets installed for you. Some tricky note here is for Windows, especially if the library you're installing is binary, or since in Windows it's difficult to get compilers, or compiling is a bit difficult in Windows, some of your options might be limited, okay? Now, the last thing to consider is update activity. What I mean is if that library is being constantly updated by the author, because you might be facing obsolescence if you have to rely on a library that was already abandoned. Also check for support availability. Although one thing that's good with actually the Python community is that for support, there's actually a lot. Directly from the library authors, you can access them through their repository, wikis or forums, or IRCs also available. And actually, I'm on Stack Overflow. Everyone familiar with Stack Overflow? Okay. I think majority of the questions there right now is Python, and usually you'll get an answer in like 30 seconds, minute. So use those things. So just consider primarily the update activity, okay, for libraries. Now, again, the solutions here are usually divided and dependent on the major versions, both of Excel that you're dealing with and of course of Python. For Excel, the jump actually occurred after version 2003. So this is actually from the old XLS format into the new Office XML format. So 2007, version 2007 onwards uses the XML format. You'll know this because the file name ends in XLSX or XLSM for the macro-enabled workbooks, and the old format, the XLS format, okay? For Python versions, there's also a major jump between Python 2 and version 3. Although I think recently a lot of the third-party libraries had already started to move towards Python 3. But I really can't guarantee with some of the other solutions out there. Usually the advice right now still is if you want a production grade, better stick with the 2.7 series of Python. But of course, there are ways to what they call future-proof your code, or make your code easily upgradable to Python 3. But that's already something advanced, and I hope probably we can discuss that sometime in some of our future meetings. Okay? Now, reasons for using Python in dealing with Excel. One is it usually is an alternative to Visual Basic. We're in Microsoft territory here. So again, the thing with this is that I'm not saying that Visual Basic is bad, Python is good, but consider something like what they're usually saying. There's no such thing, or what there's no silver bullet. There's no one solution to everything. There's no one size fits all or one cure for everything. So some people might find Python an easier language to deal with than Visual Basic. So if you think that way, and if you think that Python is more readable, better for you, I think that's one of the major reasons of using Python to deal with Excel instead of Visual Basic. Another one is as a glue. It actually exposes Excel to a lot of things that are in Python. Python excels at, let's say, scraping websites, gathering data over web pages. In Excel, you can do that, yes, but I think you have to learn years of Visual Basic to interact with those things. For Python, sometimes the solutions are already there. They come in the form of libraries. All you need to do, get the manual, do some trial and error, and you're off to go. So that's one advantage there. Take note of the batteries included things in Python. Python actually comes with a lot of things by default or standard, gets installed with Python. A lot of these things are there, including handling databases, CSV files, all of these things. And third-party libraries, I think I'll have to mention here SQL Alchemy, because this is a good library when dealing with databases. And also SciPy and NumPy. These are heavy libraries for doing data crunching. So those are just two, but I think major reasons for wanting to use Python. Okay? First case, why do you want to use Python in Excel? One is to read and write into Excel files. This is the usual case, the usual thing why people would want to use Python. Excel, we know, produces its file and use it sometimes. Probably this gets manually sent to you through email. You can use Python to intercept the email, read the attachment, and probably read the data and transfer it into your database. That's usually one case wherein Python is good at. There are a lot of things, so this is one common use. So first solution would be XLRD and Excel, or known as Excel read and Excel write. You can get the library from that link. Excel read is obviously for reading Excel files, and the other one is for writing. Right now, I just checked because I had been using the version from almost a year ago, wherein 2007 onwards has not yet been supported. But fortunately, it now supports even the XML format. So essentially, anything from 97 onwards of Excel can be read by or written into by this solution. If you're dealing with far older versions of Excel, like 95, there is a solution to that, but I don't think anybody's still using those. 95, don't tell me somebody's still with Lotus or
I did my master's project in Excel 95.
95, okay. There is a 95, a solution for 95, but this one is more mainstream now, Excel read and Excel write. Available for 2.6 onwards, so version 2.6, 2.7, and 3.2 of Python. This is a stable production grade and well documented. So this is my highly recommended solution for you. Another alternative is OpenPyXL. I'm not sure if they had already started supporting XLS, but I encountered this solution because a year ago, I don't have anything to read into 2007 files and forward. So I use this one to read XML files. Very similar to how Excel read and Excel write works. So this is something that you might also want to consider. Now, I really don't have any benchmarks for you to tell which one is a better solution, so I highly recommend that you try it out. But mostly for me, I had been using the previous one. Second use case, controlling Excel. So Excel is running, you can use Python to control it. So obviously this can only be done in Windows. This actually goes through COM automation, and you have to use the library called PyWin32 or Python extensions for Windows. This does COM automation. This is a bit tedious approach. The documentation for this is available, but you really need to try it out to learn COM automation. So instead, probably you might be interested with the third use case. as a Visual Basic replacement. So instead of trying to manipulate Excel from the outside, like ask Excel to go to this cell, place something there, instead use Python, embed it inside Excel, and access it as if it's a Visual Basic module. It can be interactive. There's one solution that's interactive. What I mean is you get the prompt, the use of Python prompt, you can play around inside. Or do it the old-fashioned way as if it's a library, wherein functions you write in Python can be accessed directly through Excel, through the formula bar, or through Visual Basic. So even on Visual Basic, you can access your Python functions. So two solutions for this, PyXLL, available for that, and Data Nitro. So these are the two generally available solutions. I'm not sure of the license for PyXLL, but I know the Data Nitro has a free version, but it also has a paid version. So try exploring this. This is actually the cooler solution. No need to code in Visual Basic anymore.
Unless you want to.
Unless you want to. Probably by now you'll be asking, so how about my charts? You have been talking about cells, writing, reading to the file. How about my charts? Unfortunately, this is currently the disadvantage. Python really doesn't have a solution right now to interact directly with the charts. My recommendation is instead, design your spreadsheet so that your chart can be updated through a table, preferably a pivot table. And use Python to read or write the cells feeding into these tables. Make sure though, of course, that your spreadsheet is set to auto-calculate. And of course, some reminders to your users to press probably Ctrl-Alt-F5 to press the pivot tables from time to time. Or if not, use automation either through Visual Basic or Python to do that refresh when the file is open. That's a solution that I can propose to you if you want to use Python to work on your charts. Or, better yet, an alternative solution for you, you can actually create reports outside of Excel. No more Excel. So there's this wonderful library called Matplotlib, or Mathematics Plotting Library in Python. It can produce excellent charts, as in almost all the charts that you can possibly imagine. All you need to do is learn how to say what you want. Because in this library, you need to say what you wanted to see. So you can produce complicated charts here, not just the basic 2D chart. You have 3D. You can even have radial plots. You can even manipulate pictures. This is a very cool library, and it has several outputs, but I think worth mentioning would be the image format in PNG. So once you use Matplotlib to get your PNGs, you can assemble this using HTML and CSS into a report. And once you have that, by the way, you assemble it using a templating engine like Jinja 2. For Django, what's your favorite? For Django? Django's the default templating is.
Just the Django
It's Django templating. I think the other templating would be Mako and
Mako Flask.
Flask. I think it goes to Jinja.
Flask is Jinja.
Jinja.
Okay. Other templating we have Mustache. There's a whole lot.
Chameleon.
Mustache.
You can swap it out.
Yeah. So essentially, you can learn any of these. Mine I mentioned Jinja because I tend to use Flask, and I'm more familiar with this one. And it uses a restructured text. So when I mention restructured text, that means you can format your report into elegant writings, because restructured text actually encapsulates LaTeX, so publication grade reports if you want. So once you have the HTML assembled with your pictures in it, you can produce a PDF out of it for distribution. There are several solutions available for Python wherein it can convert an HTML page into PDF files. But there's also actually a library in Python designed for documentation. It's called Sphinx. You can actually hack your way around it to do all of these two functions for you, the assembly and the conversion. So all you need to learn is Matplotlib and Sphinx. That's another solution. So just about me. So I'm a forecaster and in a BPO. So that's why I really don't program much. I tend to crunch data more. And of course, I stole some of those pictures somewhere, so thanks a lot. And if you have any questions for me regarding this, if you want, I think once I'm done with the slides in the Picture Coach format, I'll probably upload it on the Facebook page if you want the slides. And any questions, feel free to ask.
Anyone has any questions?
Let's go to the challenge.
Wait, I have a question.
Oh, question, sir.
Can you go to the draft? Go back to the draft slide.
The draft slide is what?
The draft.
This
Right
one
here, you have a slide for the drafts.
Ah, slide for graphs. This one?
Yeah, it's more of a idea. You said that it is hard to create graphs on Excel. I have a proposed solution. Why don't you make a Python code that talks to Win32 API that automatically moves the mouse, find the button, click the button, and then create the chart. That works, right?
Yes, it works. But it will be a Rube Goldberg solution.
Who cares? It works. It works. Yes. What's the worst that could happen? A nuclear warhead exploding by the use virtual machines.
Although visual technologies are actually about like capturing what's being seen on the screen is actually getting popular for testing, UI testing.
That's
Was that Sikuli or
Selenium.
PVBox?
I don't know the others.
Basta there's a new testing solution wherein it actually looks into the picture of what you're seeing. What's the image that's being seen? Instead of inspecting your fields through the HTML. So visual solutions are getting popular. So that's also actually
Yes.
your proposal is a visual solution. Make the mouse move. Problem with it probably is that things might not exactly fall where you're expecting them to be, especially if there's a human working with Excel.
Computers versus humans, the computer will always win. Yes.
Yes, sir.
There's actually, just to continue with that, there's actually a way to do this on via Python, but you would have to use the COM bridge. So you'd have to talk into COM to Excel to create the number. So that's actually an easier instead of clicking controlling the mouse. Because with that you can actually tell it and customize the graph, tell it a size, which worksheet.
Oh yes.
But the downside on is that it has to be on Windows.
Yeah, it has to be Windows. Actually, that was the use case to try to manipulate Excel, running Excel using Python. So yes, it involves COM automation.
Yeah.
A bit tedious. Actually, a bit tedious if you ask me.
Okay, any more questions?
Any more questions, guys?
All right.
Okay. Thanks, guys.
We have a new participant.